You big disgrace, kicking your can all over the place, singing, we will rock you. We will rock you. Buddy, you're a young man shouting in the street, you're gonna take all the world someday. You got blood on your feet, a big disgrace, waving your banner. Sing it, we will rock you. I paid my dues, time after time. I've done my sentence, and bad mistakes. I've made a few.
Welcome. In this lesson, we're going to talk about the different types of collisions. Now, one way that we can categorize collisions is into what kind of kinetic energy we have before and compare that to after. We break these down into different schemes or categories based on whether or not kinetic energy is conserved. Now, the first one we're going to talk about is the completely inelastic. Now, in this one, it says no kinetic energy conserved, but that's just a typo. In this case, the kinetic energy, there is some kinetic energy at the end because there isn't any friction, but we don't get all the kinetic energy out that we get in. Instead, these are called hit and stick collisions. So these are like two objects that hit together and stick. Now, because the objects stick, their final velocities are the same, which makes it very nice to use the conservation of momentum equation because all I do is add the masses at the end and then multiply by the final velocity of the two objects because they're the same. Now, the reason why we don't have a conservation of kinetic energy in these types of collisions is because the objects deform. They deform, you hear sound, and we get some heat out. So that energy is still there, but it's just transformed into other types. Now, on this, we can have a spectrum or a scale of inelastic collisions. Anytime that you have an object that crumples or deforms and does not restore the deformity back to its original shape, you're going to lose some kinetic energy. And here are some examples where we see some completely inelastic collisions. Now let's talk about what kind of collisions there are if the kinetic energy is conserved. In other words, the amount of kinetic energy I have at the beginning equals the amount of kinetic energy I have at the end. We call these completely elastic collisions. So they're completely elastic, which means that the objects slam together. If they deform, they reform back into their original shapes and they bounce apart. Now, because these objects don't stick together, their final velocities are different, and so we have to treat them like any other conservation of momentum problem. Now, even though on the completely inelastic, the kinetic energy wasn't conserved, momentum is still conserved, and we also have it still conserved in the completely elastic collisions. Here are some examples of some elastic or completely elastic collisions.
Check this out. Hey, that's good right there.
Alright, let's go. You got this. Ooh!
Yeah.
This is ridiculous. Keep it going.
Whoa. That is crazy.
Throw me another one.
Alright, alright.
Oh, no way. Oh, man.
Keep it up. No way.
Oh, no way. Yeah. One more. Yeah. That was crazy.
Now let's look at a third type of collision. And in this type of collision, we get gains in kinetic energy. Now these are called superelastic collisions, which is where we get more kinetic energy out than what we put in. And we see this in explosions, because explosions have zero kinetic energy at the beginning. And then whenever the explosion goes off, all of a sudden we have a tremendous amount of kinetic energy at the end. Now, these are due to potential energy, either in the form of elastic potential or chemical potential, and they're due to stresses inside the object. Now, whenever we have those collisions and those stresses come out, or they're allowed to relax, and we get more energy out than what we put in, or than what we started with, then we know we have a superelastic collision. Now, we treat these just like any other conservation momentum problem, and these also still follow that idea that momentum in a collision or in an explosion is always conserved. Now, here are some examples of some superelastic collisions.